Hey folks, this is John St. John doing another CockroachDB Bites. Today I want to talk about replication factors. So this is something that in a distributed system like CockroachDB we'll talk about. And to get started, I'll tell you that the way CockroachDB works is it splits your data into multiple ranges. Ranges are the kind of logical chunks of data that then get replicated across your cluster in what we call replicas. So different copies of the data. And replicas are what give us survivability and high availability in the face of different types of failures. So in the simplest sense, you can think about a range as being just a part of, say, a table, right? You create a table, it creates a single range. That range, by default, will have 3 replicas. They'll get replicated to different nodes in the cluster. And then from there, you'll add data to the table, insert a lot of data. And at a certain point, it's going to get big enough that we're going to say, hey, this is getting too big. We're going to split it. We're going to into 2 ranges. And now we'll have 3 replicas per range. And so we'll have 6 replicas. And those get put on different nodes throughout the cluster. So we often hear this term replication factor, and that typically refers to the number of replicas that exist in a cluster. Now, a little while ago, I'm not sure exactly when, a couple of years ago, we introduced this idea of non-voting replicas. So we have 2 different types of replicas. We have voting and non-voting replicas. And you'll hear this term a lot. So let's start with voting replicas. So CockroachDB uses the Raft consensus protocol to achieve quorum, basically a majority of acknowledgement of rights or replication of rights during the process of writing data to these ranges. So what that means is that you'll have one voting replica that's called a leaseholder, and the rights come into the leaseholder, and then they simultaneously send out to the other voting replicas, hey, write this to your local store, and when that acknowledgement comes back that it's been written, that would be considered a quorum, right? Because we have 3, so the majority would be 2. We have the leaseholder that starts it, and then we have one other one. So what are non-voting replicas? Well, non-voting replicas are something that we use to enable what we call follower reads and also low latency in a multi-region setup. So if you're working on a single region, it's unlikely that you're going to use non-voting replicas. There's reasons why you could, but in most cases you won't. But once you expand to 2 or 3 regions, typically in a multi-region setup, you don't really get a lot of benefits from a 2-region setup, but a 3-region setup. By default, we'll increase the number of replicas from 3 to 5, but 2 of those replicas will be non-voting replicas. So the way it works is that there's 2 types of survival. There's what we call zone survival, and there's what we call region survival. In zone survival, the voting replicas all stay in a single region. And the idea is that you can split those replicas across the availability zones. And an availability zone for a cloud provider is typically within a single region, you'll have multiple availability zones. And these availability zones are separated network-wise by maybe 1 or 2 milliseconds, but they're maybe in a separate physical facility, maybe different with a different power supply, etc. So it's more likely that you would have a single zone go down than have an entire region go down. So zone survival is the ability for one of those zones to go down and for everything to continue operating. So in the default configuration, we keep those 3 voters in one region, but to enable low latency, what we call follower reads from other regions, we'll put a non-voting replica in each other region. So if we think about it, really our replication factor at that point is 5, but we only have 3 voters and 2 of those are non-voters. The non-voters still follow the same write log, the raft log, and they will write those same changes to their local disk, and they can serve reads slightly in the past, generally for a follower read. Now, if we want to increase to what we call region survival, where we can tolerate a full region going down, the database will continue operating normally with reads and writes, serving reads and writes. What we'll do is the number of replicas doesn't change. So we still have 5 replicas, but now there's 2 things that happen. One is those non-voting replicas become voting replicas, so that we have 5 voting replicas. And we'll take one of those voting replicas from the original region and we'll place it in another region. So we'll have 2 voting replicas in one region, 2 in another, and 1 in the last one. So what this does is that it ensures that we can get quorum with consensus between the leaseholder region, right, the leader of the range, and the nearest region based on network latency. So as you can probably imagine, that could increase write latency a lot, depending on how far away that second region is. And for that reason, it's a real trade-off between having zone versus region survival and a low write latency versus a higher write latency. And that's largely going to depend on how far that second region is away. So just to do a quick recap on this idea of replication factor, which can mean the number of copies of data you have for any given range. In a single region cluster, typically that's 3. But as you increase to 3 regions, that number increases to 5. First, with 2 additional non-voting replicas for zone survival, and then finally with 2 additional voting replicas for a total of 5 voting replicas for region survival. Hopefully that helps to understand replication factor just a little bit better. Thanks for joining.